In this how-to video I'm going to describe how to name organic compounds and explain some of the conventions that we use. The A-level syllabus requires you to do both of these 2 bullet points. Before I proceed, what you could really do with doing before I move on is to pause this video and to actually download some documentation. The first document is contained on another page on this website, and it's the Organic Nomenclature Part 1, and that contains all of the examples that I'm going to work through in this video. The other document is this Word document, also found on the same page, which is a fact sheet which will be useful for answering the questions and working through this video, but also for answering questions and naming organic compounds in the future as you work your way through the A-level course. So if you haven't got those documents either on screen to access, or better still a printed off copy, I suggest you stop this video now, download them and print off those documents, and then start this video up again and work from there. To continue then, there are 3 main parts of an organic compound. The main section we call the stem, and this represents the carbon chain, which is the longest chain in the molecule. So the first part is to find the longest carbon chain that exists in the molecule. Often then, to prefix that before the stem, we have another part, another name, which represents anything which is added on to this long stem. So we might add on a functional group, or we might add on a branch of carbon chains or different chain lengths. And then finally, at the end of the stem, we have a suffix which basically describes the general character of what the molecule is. The best way to explain this is with examples. So this is a simple carbon molecule, and what we need to do to start off with is to count the longest carbon chain length, and that's simple in this case because all the carbons are nicely positioned in one straight line for us. So we've got 1, 2, 3, 4 carbons. Now if we look at our data sheet, we can see that a carbon chain with 4 carbons is going to have a stem called bute. So let's just add that onto the picture for a while. So there we are. We can see our 4 carbons, 1, 2, 3, 4 carbon chain length. So our stem is bute. Now if we look at this molecule again, we can see there are no side chains off this. The only thing attached to this carbon backbone are hydrogens. Here we are. These are hydrogens. There isn't anything else apart from hydrogen on this molecule. So there are no side chains whatsoever. Now, because there are no side chains, therefore there is not going to be a need for a prefix with this. So we're just going to have a stem and we're going to have a suffix. And if we look at this carbon compound again, this is a saturated carbon compound. In other words, it doesn't contain any carbon-carbon double bonds or triple bonds. Every bond is a single carbon hydrogen or carbon-carbon bond. So we say this is saturated compound. It cannot have anything added into it. And carbon compounds which are saturated, straightforward hydrocarbon compounds which are saturated, are known as alkanes. And alkanes have a common ending which is -ane. So the suffix is -ane. And if we put the stem and the suffix together, we get butane. So what we're running through this again, 1, 2, 3, 4 carbons long, which gives us a stem of bute. No side chains, so we don't have a prefix to this. and because it is a saturated hydrocarbon, because it's saturated, it's got no carbon-carbon double bonds or carbon-carbon triple bonds. This molecule belongs to the homologous series called the alkanes, with a common ending called -ane. So the suffix is -ane. So but and -ane equals butane, and this is a single molecule of butane. Now let's look at a second example, and this molecule is slightly different to the molecule we had before, and to help me, what I've done to start off with is numbered the carbons, and numbering the carbons is actually very important, and it's something that you have to learn to do and learn to add into a molecule to help with naming that compound and that molecule structure. So here is the molecule, and the first thing I've done, as I said, is I've labelled the carbons to get the longest chain length. So if we count the carbons, 1, 2, 3, 4, 5, the longest chain length is 5 carbons long. And you might look at this molecule and say, well, what about this carbon? Equally, this chain length works, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. The longest chain length is 5. So for ease of drawing and for explanation, I've numbered it in this direction. And so the first thing we do then is to work out what the stem name is. So looking at our fact sheet, we can see our longest chain length is 5, so that gives us a stem of pent. So now we have to re-inspect the molecule, and if we look at this molecule, yes, we've got a spine or backbone of 5 carbons, but off that we've got a spur or a side chain, and this side chain is a CH3 group. And if we look at our fact sheet, we can see that the CH3 group is called a methyl group. So this molecule has a prefix which is going to be methyl, but it's not good enough to just say it's a methyl group, because where is the methyl group? It could effectively be here on this carbon, or it could be on this carbon. So this is where the numbering becomes very, very important. In this case, the CH3 group is on carbon number 2. So the prefix becomes 2-methyl, because the methyl group is on carbon 2. If the methyl group was on carbon 3, in other words here rather than here, the prefix would be 3-methyl. So we have a prefix in this molecule, 2-methyl, pent, and then what we now need to do is to re-inspect the molecule yet again, and if we re-inspect the molecule yet again, we can see it's a saturated hydrocarbon, all single bonds, so we know this is an alkane. So if we add that information onto the diagram, putting all the parts together, then we have our prefix, we have our stem, and we have our suffix. The compound named is 2-methyl pentane. Now it's very important to look at this molecule and to consider some other facts which are on our fact sheet which I've given you. And this is the key fact: when we name compounds, we use the smallest numbers possible. So in the example I've just illustrated, we have a compound which is 2-methyl pentane. If we'd have numbered from this end, shall we say, 1, 2, 3, 4, 5, what we'd effectively have, we would have 4-methyl pentane, and that would be wrong, because 4 as a number is bigger than 2, and we always number to get the lowest set of numbers that we possibly can. So in this case, the lowest set of numbers we can have to illustrate the methyl group is at position 2. So let's now look at another example, and I've put all the annotation and markup on the example to talk through rather than put it on in stages. First job then is to work out what the stem is, and again I've added numbers, and we can see we have a maximum carbon chain length of 7, so the stem is going to be hept because it's 7 carbons. And now if we inspect the molecule, this time we have 2 branches. We have a branch at carbon 3, which is a 1 carbon group, which is a methyl group from our fact sheet, and we have a branch again at carbon 4, and this branch is 2 carbons, so it's an ethyl group. And same annotation as with the last example, we have this time we've got 2 prefixes, haven't we? We've got 3 methyl, 4 ethyl, and finally, inspecting the molecule once again, we can see it's a saturated molecule. All of the bonds are single, so it's an alkane, so the suffix is -ane. And if we put all these pieces together, we get an overall name of 4 ethyl, 3 methyl heptane. And there is another convention being illustrated here, and the convention is when you're naming the compounds is when we're talking about the prefix, we always name the prefix alphabetically. So ethyl becomes before in the alphabet before methyl, so the name is 4 ethyl, 3 methyl heptane. And there is another convention being illustrated here. Wherever we have numbers next to letters, we separate the number and the letter with a hyphen. So in this case, 4-ethyl, -3-methyl heptane. Another important convention. Let's move on to another example. In this molecule, I've actually introduced a double bond. So what we've got here is a molecule which is not saturated because it's got a carbon-carbon double bond. And again, we follow the same rules and naming conventions. What I've done is I've numbered the carbons again. 1, 2, 3, 4. And the stem then is 1, 2, 3, 4 carbons long. So the stem of this molecule is bute. And because it's a double bonded, or it contains a double bond, it is no longer an alkane. It belongs to the homologous series of alkenes, and this has a suffix of -ene on the end, as in alkene. So we could have ethene, butene, heptene, etc. But the position of the double bond is important, and we have to be able to illustrate that in our answer. So if we look at where this double bond is, it's actually between carbon 1 and carbon 2. So we know we've got a stem of bute, and we know we've got a suffix of -ene. There isn't any other substitution in this molecule, or hydrogen bonded to carbons. So we don't have a prefix. But what we have to do is we have to be able to note where that double bond is, because the double bond could actually be there. And the way we do that is again with a convention, and the convention is we number where the double bond is with the smallest number. So if we look at the actual name of this molecule, it's bute 1-ene. It's an alkene, 4 carbons long, and the double bond between the carbon and carbon is between carbon 1 and carbon 2. Putting all that together, bute 1-ene. Now this stuff needs some practice, and hopefully this video will be a stepping stone to help you along the way. Thanks.